So today will be our second lesson with integers, and we're going to look at multiplication. But we're going to start off by learning how to write repeated addition as a multiplication expression. So I think we've seen this before. What I want you to notice is that the ones are being added 5 times. And therefore we can actually change this so that it's 5 multiplied by positive 1. Which we can simplify just to 5 multiplied by 1. We don't need to write this positive sign. In fact, it doesn't matter the order of this. We can also write this as 1 multiplied by 5, and both ways we'll get the same answer. For B, we have minus 6 being added 3 times. And therefore I can write this as 3 multiplied by negative 6. And again, the order of multiplication doesn't matter. Just as you know 2 multiplied by 5 is 6, 2 multiplied by 3 is 6, and 3 multiplied by 2 is 6. And so we can write this as negative 6 multiplied by 3 as well. So now if we want to go backwards, so we have positive 3 multiplied by positive 8, I can say that this is the same as positive 8 plus positive 8 plus positive 8 3 times. And if I actually simplified this piece here, notice that this would equal 24. And we also notice that 3 multiplied by 8 is 24. So in both cases, of course, we would expect to get the same answer, but we've just proven that we did. In B, we have positive 5 multiplied by negative 4. So I can rewrite this as negative 4 plus negative 4 plus negative 4 plus negative 4 plus negative 4 5 times. And what I want you to notice is that if I add all of these together, I would get minus 20. Now notice that 5 multiplied by 4 is also 20. And because the answers would be the same, a positive multiplied by a negative is going to be a negative, and therefore positive 5 multiplied by negative 4 is also equal to negative 20. We're going to make those rules in a second too. What if we want to using these diagrams, if we want to write them as a multiplication statement? There are two ways to look at it. If I was to look at it like this, so I have 3 there and I have 3 there, then I would have 2 multiplied by 3. The other way that I can look at it is that I have 2 here, 2 here, 2 here, and therefore I have 3 of them, and there's 2 in each group. Notice that both are just 6. So again, order of multiplication doesn't matter. Here I can look at this as one group, and there's 1, 2, 3, 4, 5, 6, 7, 8 in the group. So I could write this as 1 multiplied by 8. Alternatively, I could also write this as 8 multiplied by 1. You could consider each one as its own group, and there's 8 of them, so we multiply by 8. Both of those ways are perfectly correct. Alright, let's look at some without some diagrams. So if I have positive 4 multiplied by positive 6, now this one we know, okay? We generally don't write the positive signs in here, but it's just really because we're talking about positive and negatives, because we're looking at integers, and therefore our answer we should guess is 24. In our next question though, we have a negative 1 multiplied by a positive 2. Now if you did look at the expanded addition version, we would have negative 1 plus negative 1 2 times, so negative 1 plus negative 1 2 times, and we would see that we get negative 2. And the reason I've shown you this is that I want you to get used to the fact that a negative multiplied by a positive, in fact, is going to be a negative, and 1 multiplied by 2 is 2. The negative sign is just talking about direction. So we always try to we start off by going forward. And unless it's stated otherwise, we're talking about forward. As soon as it tells us that we have a negative, it's changing the direction on us. So we're now going negative, which is why we get negative 2. Now the next one is a little different. We have a negative and a negative. So of course, it's the same idea with direction. We start off going positive, and then our -2 switches our direction, and we go negative. But then we get to the -3, and there's another negative sign. And therefore, I have to change my direction again. And now I'm going in the forward direction, the positive direction. So my answer, in fact, a negative multiplied by a negative is positive, and 2 multiplied by 3 is 6. Alright, the general rules is a positive a, or a positive number multiplied by a positive number, is a positive number. A negative number multiplied by another negative number is also positive. A positive multiplied by a negative is going to be negative. And finally, a negative multiplied by a positive is also negative. So if you have multiplication and one of them is negative, then the whole thing becomes negative. If both of them are negative, then the whole thing is positive. Alright, so we're going to move into a little bit of a different direction. We want to look at squares, square roots, cubes, and cube roots. So just starting off, we know that we can write 4 squared as 4 multiplied by 4, which is also equal to 16. Because 16 can be written as 4 to the power of 2, so it's 4 multiplied by 4, so it's the number multiplied by itself 2 times, we call it a perfect square. And if we take the square root of 16, the square root of 16, basically the square root, we're just looking for a number multiplied by itself that equals this inside number. And in fact, 4 multiplied by 4 is 16, and therefore the square root of 16 will equal 4. So I know you guys have seen this before, so just a little bit of a refresher there. The next part gets a little harder. What if I want to take the square root of 441? That's a big number, and I don't know what the square root of it is off the top of my head. So my first step is to do a factor tree. So I'll do my factor tree here. I'm going to divide it first by 3. And the reason I did 3 is because notice that 4 plus 4 is 8, plus 1 is 3, and 4 plus 4 is 8, plus 1 is 9, and 3 divides 9 perfectly. Therefore, I can divide this by 3. So it's 441 divided by 3. 3 goes into 4 one time. The remainder is 1. I pull down the 4. 3 goes into 14 4 times, and that's 12. My remainder is 2. I pull down the 1. And 3 goes into 21 7 times, and my remainder is 0. Therefore, 441 divided by 3 is 147. Now, if I add these together again, I'm going to get 12, and 3 is also divisible by 12. So I'm going to do 3 again. If you're not sure, do the long division. So it's 147 divided by 3. The closest 3 gets to 14 is 12. I have a remainder of 2. I pull down my 7. 3 goes into 27 9 times, and I get 0. And a good one to notice here is that 7 multiplied by 7 is 49. So knowing our times tables is a little bit important here. Okay, so I've done my factor tree. I've got my prime factorization because all of my leaves are prime numbers. Now, we're trying to find the square root. So we're essentially trying to make groups of 2 groups where both group 1 and group 2 have the same numbers with them. Well, if I take this 3 and I put it here, and if I take this 3 and I put it here, then I take this 7 and I'm going to put it over here, and I'm going to take this 7 and I'm going to put it over here. Notice that one thing that you want to remember is that 3 multiplied by 7 multiplied by 3 multiplied by 7 is equal to 441, which is why I've got these multiplication symbols in between here. And the reason I've done this is notice now I have 2 groups that are exactly the same. So I can rewrite this as group 1 is 21 and group 2 is also 21. Well, I can rewrite this as 21 squared. And we're trying to find the square root of 441. So the question is, what number multiplied by itself twice is equal to 441? Well, that would be 21. Okay, we're going to look at cube roots. So one thing that we do know is 2 cubed, we can write it in expanded form as 2 multiplied by 2 multiplied by 2, and if I simplify, I get 8. Now, because 8 can be written as 2 cubed, so because it's 2 multiplied by 2 multiplied by 2, we call this a perfect cube. Okay, and that's because it's a number multiplied by itself 3 times. Now, if I want to take the cube root of 8, so what number multiplied by itself 3 times equals 8, we would get 2. So that's pretty simple. But what happens if we want to take the cube root of something bigger like 216? Now remember, we're trying to take the cubed root of 216. So what I want is what number multiplied by itself 3 times equals 216. So I'm going to do the same process as the last one. My first step is to do a factor tree. So 216, it's an even number, so let's do something easy. Let's just divide by 2, and that's 108. Again, it's an even number, so I'm going to divide by 2. I get 54. Again, it's an even number. I'm going to divide by 2. 54 divided by 2 is 27. Now 27, if you don't see it right away, 2 plus 7 is equal to 9, and 9 is divisible by 3. Therefore, my next divisor is going to be 3, and I get 9. And finally, this breaks down to 3 and 3. Okay, so what do I have right now? I have that 216 is equal to 2, and I'm just taking my leaves, right? They're all prime. So it's 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 3 multiplied by 3. Now, because I'm taking the cube root, I want the number that's multiplied by itself 3 times. So I'm going to go like this. I'm going to make 3 groups. So I'm going to start off by putting one of these 2's in each group. Okay, so I've taken care of all 3 of those. Then I'm going to take one of these 3's and put them in each group. Now the nice thing about this is I can simplify, and the reason I've made it into groups is because notice that this is the same as this is the same as this. So I'm going to simplify my groups, and I get 6 multiplied by 6 multiplied by 6. So again, I'm going to go up to my question, which was what number multiplied by itself 3 times equals 216? And it's 6. 6 multiplied by 6 multiplied by 6. And therefore the cube root of 216 is equal to 6.